help you. I'll put it on YouTube. I'll send you the link. I'll email you the link, okay?
Okay, sounds good.
Not Khan Academy or something. It's just for my own students.
Sounds good.
All right, let's do one of these guys. Just says simplify.
Okay, just give me a second. Just write it down.
What else are you taking this semester apart from maths?
Chemistry and physics.
All right. How are you in those?
Chemistry, I'm okay. Physics, not the greatest. It's probably my weakest subject, I'd say.
Okay.
Okay, so we can bring down the negative 2D to make it positive.
No, you can't. Again, you can only bring down stuff
only when
if it
it
has
has
a
an
negative. Yeah.
Okay.
But even if you see right here, this is a little bit different. Let's say you had d minus 2 minus 3 over something like this, okay?
Yeah.
You cannot bring this d minus 2 down because it's being subtracted with the 3. If it was by itself, the 3 didn't exist, yes, you could have brought it down, but there's a minus 3 here, you cannot bring this down.
So can you bring the 3 down and just make
Here
it
you
positive?
can't bring anything down. This is not that unit. This is a different unit. This is simplifying like quadratics unit. So we won't be bringing anything down.
Okay.
So we're just gonna kind of factor them out, okay? And I don't know if you've done, you have done this in both grade 10 and 11.
Yeah.
Yeah, so I'm gonna teach you a way that I like to call the MAN method, okay?
Okay.
It's M-A-N. Over here in the books, they do it with tiles and whatnot. I think that's a little bit goofy. Let's try this. So this works for a quadratic trinomial. Now let's look at what both of these terms mean. Quadratic means the maximum power of whatever is 2. You see this entire term? Maximum power is 2. That's a quadratic. Same thing here, 2, quadratic. But this is not a quadratic, that's a linear. Right. So that's first quadratic. And then trinomial means the thing has 3 terms. You see 1, 2, 3, 1, 2, 3, 1, 2, 3. All these 3 guys are quadratic trinomials apart from 3D minus 1. So when you have a quadratic trinomial, you want to factor it, okay? And how do you factor it? Use the MAN method. And how does this work? M stands for multiplication, A stands for addition, N is the numbers. So you are looking for 2 numbers, right? Bear with me for a second. You're looking for 2 numbers. When you multiply them, you get the coefficient of this power, right? D squared, which is 1, with the C value. And every quadratic has this format. So when you multiply them, you're looking for A times C, which in this case will be 1 times minus 3 minus 3. Okay. And when you're adding them, you get the B value. What's the B value here? Minus 2. So tell me, what are the 2 numbers? When you multiply them, you get minus 3. When you add them, you get negative 2. The set is the same.
1 minus 3?
1 minus 3, yeah, that works, right? There we go. So those are our 2 numbers, right? And you see the coefficient of the quadratic here is 1. The leading coefficient is 1, yeah? Yeah. So this thing automatically factors into D plus 1 times D minus 3. Okay. Okay, that's one of them. And
then you just do for all of them, 3D one,
yeah.
right?
Yeah, you do for all of them. Now let's look at the next one. What does this multiply to?
So it means multiply to -1?
No, AC, right? AC.
Okay. So -2?
Yeah. What does it add up to?
It's supposed to add up to 1.
Yeah, adds up to 1. What are the numbers?
Just on 1 second. -2 and 1?
The other way around.
Oh, sorry, 2 and -1.
Yeah, 2 and -1. But now the coefficient, the leading coefficient is not 1. So this won't be a one-step factorization, all right? We're going to play with this a little bit. So we had on the side, I'm just going to do this on the side. So we had 2D squared plus D minus 1, okay? And again, whatever numbers you get down here, you want to replace the D in the center with these 2 guys. So the next step is 2D squared plus, you see the D? You're going to rewrite this as 2D minus 1d minus 1. So we basically replace the plus 1d with plus 2d minus 1d, which is d. But we want to factor this two things at a time in order to take it into this form.
Okay, so when do you do this when like it's more than one?
You do this quadratic trinomial when the man method works out. When you're able to get these two numbers for a quadratic trinomial, you want to distribute the middle guy, yeah, the one with the power of 1, into these two guys.
Yeah, but you didn't do it like the first one.
We could have done it, but first one, if the leading coefficient is 1, it works out automatically. But we could have done it here. Check this out. So minus 2d minus 3, what were our numbers? It was minus 3 and 1, yeah?
Yeah.
Minus 3 and 1. So what we're going to do is going to rewrite this as minus 3d plus 1d minus 3. Okay?
Okay.
What can we pull out from the first two terms?
Just the minus 3d and the 1d becomes negative 2d, right?
No, yeah, it does, but we're working forwards, not backwards, right? So we're gonna
All right.
we're gonna take something out from this term and this term. See, they both have a d in common. We're gonna pull that out, and in a bracket we will have d minus 3. You see that? D times d is d squared, d times minus 3 is minus 3d.
Okay.
Then we're gonna do the same thing for the next two terms. They have nothing in common. So when they have nothing in common, you can pull out a 1. And then in that bracket, you have d minus 3.
Okay.
You see this? These two brackets will always be the same. Whenever you're doing the man method, these two brackets, if these numbers work out, they should always be the same. And the next step here, okay, to understand the next step, you have to understand this. If you have d times a plus 1 times a, if I pull out an a, what am I left with in the bracket?
The d?
Yeah, but not just d.
Well, d plus 1.
Yeah, exactly, all right? Now notice these two brackets are our a. Okay, so I'm gonna pull out these two brackets, the entire bracket. What am I left with? I'm left with d plus 1. And there we go, that's what we have up there. But when the leading coefficient is 1, you don't have to do this extra steps. You can literally just write it in one step.
Sorry, so you just, okay, so I'm just a bit confused. So d plus 1, where do you get that from?
Here, look at this, okay? We pulled out an a, right? If
Yeah.
we were to pull out an a, what do we have left in the bracket?
Just the d plus 1.
Yeah, so that's what we did for this thing as well. You see
Oh,
this
so
entire bracket is a. This entire bracket is a. So we pull that out, d minus 3, and then we're left with d plus 1 in the bracket.
So you pulled out d minus 3.
Yes.
Oh, okay, I see. But so but there's two a's and you only pulled out one. Because
yeah, exactly. There's two a's, but you only pull out one. Because when you open this bracket, you would get your two a's back.
Okay, I see. But it doesn't matter which one you pull out?
No, it does not. It does. They're both a's, right? You could have done d plus 1, d minus 3 as well. Yeah. Is this what you mean?
Yeah, just pull it out. So yeah, okay, I understand.
Yeah, you could. Yeah, this is fine too. So it's the same thing. Okay. Well, what I'm trying to tell you, the main step here is that when the leading coefficient is 1, right? When the leading coefficient is 1, you don't have to show all the exactly. We had this thing. You could have just straight up written d plus 1, d minus 3.
Okay, sounds good.
But here, when the leading coefficient is not 1, we are going to have to do this the long way that we just did. Here, let's do this. So from our man method, our two numbers were 2 and negative 1. So I'm going to rewrite the d in the middle as plus 2d minus 1d. Okay, and now we're going to factor this two things at a time. Look at the first two terms. What can I pull out?
The d?
Yeah, but something else as well. 2.
2d, right. 2d.
Well, what am I left with in the bracket?
d?
Yeah.
2d?
Yeah.
And just 2, right?
No, plus 1, right?
Oh, right. Where do you get the plus 1 from?
Because 2d times 1 is 2d.
Okay. Yeah, okay. Right. Okay, makes sense.
Now from the next two terms, right, we can pull out a minus 1. Yeah?
Okay.
What am I left with in the bracket?
D minus 1.
A plus 1, right? Negative 1 times plus 1 is minus 1.
Right,
if this was a minus here, this would have been plus. So it's going to be a plus 1 in the bracket. And notice again, these two brackets have to be the same.
Right.
They will always be the same as long as these numbers exist. Okay. So what's the next step?
You just get rid of the a. So yeah. Yeah,
Yeah.
so it becomes 2d minus 1 and then d plus 1, right?
Yeah, exactly. Perfect. There we go. Now we just need to do this once more from the bottom guy. Okay, let's do the same thing for the bottom guy there. What do they multiply to?
They multiply to -7.
No, they add up to the b, right?
Wait, 1 second. Yeah, they multiply to 2 times 3, which is 6.
Yeah.
And then they -7, right?
What are the
So
numbers?
1 second. So 2 times 3. Well, that can't be, no.
Yeah, no, 2 times 3 doesn't work.
So 6, -6 and 1. -6 and -1.
Yeah, there we go. All right.
Yeah.
So now we're gonna do the same thing. We're gonna rewrite the -7d in the middle, right? And once you get a hold of this, this will be very quick. We're gonna rewrite -7d as -6d -1 plus 3, -1d plus 3, like that.
Yeah, and then you just take out the d.
Something
Right.
else as well. We can take out something
2d,
else.
the 2d.
2d. What am I left with?
You're left with d.
Yeah.
-1.
-3. All right, 60. 2d times -3 is -60.
Oh, that's 6. Okay, sorry. Yeah.
Yeah.
Okay.
What about the next? What can we take out from these two?
The -1.
Yeah, good. What am I left with in the bracket?
The d and the -3.
Yeah, perfect. And there we go. 2d minus 1, d minus 3.
Yeah, 2d minus 1. Okay, perfect. I'm starting to get the hang of it.
Yeah, once you get a hang of it, it's pretty fun, actually.
Yeah, it's the first time I've seen this method. That's why I usually don't do the man method. I just do an array. But this is like, I think, easier, I guess.
Yeah, okay, now we're gonna see there's a minus sign in the middle. So that means we need to find the lowest common denominator between these two terms. So here's a quick check, actually. 1/2 minus 1/4. What's the lowest common denominator?
1/4.
Yeah, exactly. It's just 4, right?
Yes.
What we can look at this as is this. What if this was 2 times 3? What would be the lowest common denominator?
Would it not be still the same?
Yeah, it'd be 6, right? Or 2 times
Yeah,
3.
yeah.
What if it was 2 times 3 and then over here you had 2 times 5? What is the lowest common denominator?
That'll be the one to the right. 2 times 3.
No, it's gonna be, you see, they both have a 2. That's
Oh,
one.
one of them is negative? Is that why?
No negatives.
Or-
It'll be this. So whatever they have in common, you write that once, okay? And everything else, what they don't have in common, that comes as well. So this will be the lowest common denominator for both of them. So what is that? That's 10, right? 110 and 6. What is it?
Oh, 1 second. So it's 110, 16, and then 115. Do we have that?
So what is this? This is 30, right? So 30 is a denominator that goes into both of them. So that's good. So again,
Oh,
whatever
okay.
they have, both common, you write that once, okay? And everything
you-
else, yeah, you write it once, right? So same
Oh,
idea
you're right.
applies to these.
So you just write it like you just write it over once, and
Yeah.
then you just find what
Here,
they'll
let's do
have.
another one. Let's do another one. 3 times 6 times 10. Okay, and this is just for show. This is not going to be like truly accurate. 5 times 6 times 10. So tell me, what's the lowest common denominator here?
So you have 1, 3, 3 times 6 times 10.
Times 5. Yeah, exactly. You got a hold of it? Repeating, you just write it once, and then everything else you write it.
Whatever is new, you just put it, but
Yeah.
if it's repeating, you just put it once. Okay.
Yes. Now we're going to use the exact same idea here. So what will be the lowest common denominator for these two?
Oh, okay. I'm starting to remember this. So it becomes 2.
So it's
times-
going to be this term, right? We're going to write it
Yeah.
once, right? We're going to write that
So
term
it's
once.
d minus 1, and then d plus 1, and then d minus 3, right?
Yeah, exactly. There we go. D minus 3. It's going to erase this. We don't need any of this anymore. Okay. So what this means is that this term, we need a d minus 3, yeah?
Okay.
So
Yeah.
we're going to multiply this with d minus 3 on the bottom, and then we're also going to multiply it with d minus 3 on the top, so that they have a common denominator and we can subtract them.
Wait, so you do the same thing for the top as well?
Yeah. So you want to add it here, and then because if you cancel them out, you go back to this step. So you're allowed to do this.
Yeah, I understand, but what do you do for the 3d minus 1?
Where's the 3D minus 4? See
3D
these
like the
two
one to
terms?
the
Yeah,
right. Yeah, I get that how they cancel each other out. Yeah, but I don't understand. Like the D plus one cancels each other out. The D plus one
Okay,
cancels.
yeah, exactly. Yeah. So we could have canceled this one actually here. So we actually didn't need that here. So let's do that. Let's do that first. I didn't notice that. D plus 1 canceled out. So our term becomes this. D minus 3 over 2D minus 1 minus 3D minus 1 over 2D minus 1 D minus 3. Now what's the lowest common denominator?
It's just 2D minus 1 and 2D minus 3.
Yeah, D minus 3, right? So it's this guy.
It just was to the right. Yeah.
All right. So what does this guy need? This guy needs an extra D minus 3, right?
So you just add it, right?
Yeah, you just add it in the bottom. But when you add it in the bottom, you have to add it in the top as well.
Right.
Okay, there we go. And now we can combine this because they have the
And
same denominators.
And the D minus 3 just cancels each other out, right?
Oh no, these two.
Yeah.
Uh, these two they do, but if you cancel them out, they won't have the common denominators. You can't subtract them. The goal is for them both to have the same denominators, so you can subtract them and you can combine them. Yeah, these two cancel each other out, right? But they won't have the same denominators anymore.
Okay.
So that doesn't help you. So we're gonna combine them, and then what was the common denominator? It was just this. And then let's FOIL this. FOIL means it just means open the bracket.
So it just becomes one big thing, right?
Yeah.
Like,
So
like D minus 3 times D minus 3 minus 3D.
yeah, exactly. So what's D minus 3 times D minus 3?
It's just D squared.
Yeah.
Minus 9.
No, that's a very common mistake. It's gonna be D squared minus 6D plus 9. You can do it on the side here. Let me close my window.
Oh, you can just do it in an array. Yeah, it'll probably be.
Yeah. Why don't you do it? Just tell me if you get the same thing.
Okay, I'll just do it in an array. Yeah, it's negative 6D. So it's x. So I subbed an x for D. So it'll be D squared minus 6D plus 9.
Yeah, exactly. And then we're gonna subtract 3D plus 1. All right. You didn't realize how this became a plus 1. The minus 1 there became a plus 1 here.
How come?
Because there's a minus sign in the middle, right? Try opening this bracket. This term will become a plus.
Oh, okay. So yeah, I can make sense.
And then we can clean this up. So the final step is D squared minus 9D plus 10 over D minus 3 to D minus 1.
So D squared minus 9. Yeah, so you just put it together.
Yeah,
so
exactly.
it becomes 10. Yeah, okay, makes sense. Okay, I see what happened.
And then we're done.
And that's it. You can't go any further.
Yeah.
Okay, makes sense.
So the goal is for them to have a common denominator, so you can subtract them and combine them into like one unit.
Makes sense. Yeah.
All right, let's move on from this. They're all the same. As long as you can do one, you can do all of them.
Okay.
Let's do this. It says simplified to mixed radical form.
Okay.
You remember this?
I not really. I remember doing it, but I don't remember it.
Here, let's do a couple of quick examples.
So when you just divide 12 by 3, can you do that?
Yeah, this one you could. Yeah, that's gonna become 4 root 60 over root 12, right?
12. And then you can do 60 over 12 on mine.
Yeah, you can do that as well. So it's gonna become 4 root 5.
Yeah, that's the answer, right?
Yeah, that's the final answer.
Okay,
this one was very easy though. It didn't.
That one was easy.
Yeah. This one's gonna be a little bit more difficult. So what's the goal here? We need to rewrite this. You see this radical here as a mixed radical. Now, how do we go about doing this? So the way this works is, let's look at root 40, okay? You are looking for the biggest perfect square, okay, that you can fit in 40. So what's the biggest perfect square? By the way, what are perfect squares? You know, like 1 squared is 1. 1 doesn't really count. Like 4, 9, 16, 3 squared, 4 squared, like these guys, okay? These are
Yeah,
perfect
like
squares.
yeah, okay, makes sense.
So what's the biggest one that goes into 40
Uh,
out of these guys?
4.
4, right? Yeah, exactly. In fact, you don't have to look for numbers that are like bigger than half of this. So half of this is 20, right? So you don't have to even look for numbers like these numbers. You can just look for these. So it's going to be 4. We're going to rewrite root 40 as root 4
And then
times
just,
root 10.
okay, yeah, I see what's happening. So you're basically expanding it.
Yeah.
Okay.
And then you can rewrite this in case you don't understand this step. You can rewrite this as root 4 root 10, right? Root
Yeah.
4 is 2, and then you get 2 root 10, and there you go. That's the simplified version.
Oh, okay. Okay, I see.
Now we're going to do the same thing for this guy, root 27. What's the biggest perfect square that you can fit in there?
3.
9, right? 9.
Oh, right. 3 and 9. Okay, yeah.
So we can rewrite that as 3 times 9. Okay, like that.
3 times 9. Yeah.
Yeah.
Okay, makes sense. And then you can do the 9 becomes a 3.
Yeah, exactly. So 9 becomes a number 3,
Just
root
right,
9. And you can
yeah.
multiply that with the number outside 4.
So it becomes 12,
yeah.
3
Yeah, exactly.
minus 6. Yeah. And then, yeah, that should be it, right?
No, you can pull out something in the numerator. Tell me what you can pull out and what would be left in a bracket, because you can cancel this.
In the numerator,
Yeah.
you can pull something out.
Yeah.
You can the negative 6, maybe?
No, just 6. Because 6 goes into both 6 and 12, right? So you can pull out a 6 from both of them.
Oh, so you just put the 6 outside. Okay, well, you just do 6. Well, 6 times 2 equals 12. And then, so 6 times 2 is 12. And then you want to get the square root of 3?
Yes. Minus what?
So 6.
6 times something is 6.
Okay, 6 times 1.
Yeah, there we go. Okay, and then these two cancel out, and then the final answer has no denominator.
Okay.
That makes sense?
Yeah, kind of makes sense.
So the radical perfect squares you're looking for.
So what you did is just you put this, you just other than like, you just put the 6 outside, and then you made 6 times 2. You just, okay, I see what you did. Okay, makes sense. Well, like, it's negative 6. How did you just like put it outside the bracket? You're allowed to do that?
Where? No, I just pulled out a 6 though, right? See, this works. 6 times 2 root 3
Oh,
is
it
12
becomes
root 3.
negative 6. I see.
Yeah.
Okay, makes sense.
Like if you wanted to, you could even pull out a negative 6. It just makes life harder. Here you'd get minus 2 root 3, and then here you'd get plus 1.
Yeah, okay, makes sense. I see what happened. Okay, cool. Yeah, so this just equaled everything that's there, but you just basically expand it. Okay. And then it's okay. That makes sense.
You know, it says solve for x using factoring method or quadratic formula.
Solve
right.
for x.
So you'd use the quadratic formula if the man method doesn't work, or if you can't find out the numbers for the man method, okay? What does it multiply to?
Multiply, it's negative 12.
Yeah, adds up to
11.
What are the numbers?
Well, it can't be 6 and 2. It can't be, it's negative 12 and 1. No, 12 and negative 1.
Yeah, there we go. So we're going to rewrite 11x as plus 12x minus 1x minus 2 equals 0.
So it's 6x squared plus 12x minus 1x minus 2. Okay, cool. Yeah.
Now what can we pull out from the first two?
You just don't use the 12x and the minus 1x?
You want to do this? Then we would go backwards. No, we can't.
Oh, right. We don't want to go backwards.
No. So we're going to pull out something from the first two terms, whatever they have in common.
Oh, you can, they have a 3 in common.
They have a 6
in common. Oh, right. So it just becomes x squared plus 2?
No. You always want to pull out the maximum.
Bracket? Is that what you're doing?
Yeah, exactly. Yeah. gonna open a bracket, and when you're opening a bracket, right, when you're pulling out something, you always want to pull out the maximum things that you can pull out. 6 and 12, pull out a 6, x squared and x, you pull out an x. Now the question is, what's in the bracket?
So 6x, and then you have x.
Yeah.
And then 2.
Yes. Yes. What about the next two?
That's -1x -2, right?
Yeah.
So you just get the -1 out,
Yes. And what's in the bracket?
and then you have x plus 2.
Yeah. Notice these brackets will always be the same.
Yeah.
And then you have 6x minus 1 times x plus 2 equals 0.
Okay.
Right? But this question, you understand this step? How did we get to this?
How did we get to what? Sorry.
The final step here?
So 6x minus 1. Oh yeah, you just got rid of the a. That's
Yeah,
what we call
exactly.
it.
Yeah, exactly. So now what we're going to do is this question's asking us to find the x value, solve for x, which is the x-intercepts. We're going to set these brackets individually equals to 0.
And then you just find the x for each
Yeah,
one.
exactly. So
So
6x
6x
minus.
minus 1.
So what do we get for x for the first one?
You just add 1.
Yeah.
Isn't it 1/6?
Yeah. What about the second one?
That's x plus 2, right?
Mhm.
So it just becomes 2, -2.
Exactly. So these are your x-intercepts. If they asked you to graph this, this is what, 0.1 something.
And then you sub them in, correct?
If you sub them in, you would get a 0. You don't have to sub them in. What this
Oh,
means
you
is
don't have
that
to.
this just means these are the x-intercepts or the solutions to this problem. Okay, or let me show you what this means graphically. Okay, -1, and then let's say this is -2. You see at -2, there's an intercept, x-intercept. Okay? And then 1/6 is like 0 point something. I'm gonna assume that is 0 point something. Here, there's another x-intercept. Okay, where's the y-intercept? Look at the question.
So y is -2.
Yeah, the y-intercept is at -2, so -1, -2. And this is a positive quadratic, right? You see the leading coefficient is positive. That means it's going to open upwards like a U, and there we go. There's our graph.
Okay.
Goes through the two x-intercepts, goes through the y-intercept. Okay.
Yeah, I'm starting to understand. They're all kind of very similar.
Yeah. All right, here, let's look at this one. Again, it's asking us to find the x-intercepts or solve for x. We're basically trying to do this if we can.
Okay. Do you first square root it? Just get the
No, you can't square root it. So the goal is to make one side equals to 0 so we can test for the
just
man method.
-3x squared?
Let's make this positive, right? So we're gonna move
Oh,
both
and
of
then
these.
we just add 4.
Like that.
Oh, this is just easier to solve. Okay.
Yeah. So let's try and see if man's gonna work. They
Yep.
multiply to 12, they add to -2.
Yeah.
Does it work?
12 and -2. Okay. So 6 times 2, that can't be it.
Yeah, nothing works. 3, 4 doesn't work, and then 1, 12 doesn't work either, right? So there are no numbers that exist for this. So you can't factor them. That all this means is that you can't factor them like we did here.
Right.
But the x-intercepts could still exist, okay? They could still exist. So for that, you're gonna have to use the quadratic formula. So you're gonna compare this with this, ax squared plus bx plus c.
Okay.
Quadratic formula says this, x is equals to -b plus minus b squared minus 4ac all over 2a.
Sub them in. You just sub them in.
Now you just sub them in. Minus b becomes a +2 because you have -2, right?
Yeah, +2. And then, oh, but you'll have two different answers, right, though?
You'll have two
Oh,
different.
yeah, you want two x-intercepts, yes.
Yeah, exactly. Then b squared is just -2 squared, which is a 4, right?
Yeah.
Minus 4 times 3 times 4. Actually, you can't do this. Notice if you do this, you'll get a negative inside a square root. So what this means is that this question cannot be factored. It also does not have any x-intercepts.
Oh, so you can't solve it.
You can't solve it. It has no x-intercepts. So the graph of that, again, we know the y-intercept is 4, right? Would probably look something like this. It'll never cross the x-axis.
Oh, okay.
So it has no solutions. Okay.
Oh, okay. I see.
And then this thing gives it away, right? If this is a negative, you can't take a square root of a negative number. So that gives it away that it has no solutions.
Oh, okay.
Actually, if you're intrigued, I'll show you something. You can do this. I'm telling you, you can do that, but not just, I know some teachers teach it. Let's look at that in more detail. 4 minus 4 times 3 times 4 in a square root. What is that? That's 4 minus 12 times 4, 48. This is the square root of, let's say for our sake, right? Let's say for our sake, you get negative root 49.
Okay.
Now you've seen this, right? X is an element of all real numbers. Have you seen this?
Yeah. X can be anything.
Yeah, okay. So in this system, this has no solutions, okay?
Mhm.
But there is another system where this does have a solution. And for that, you're going to have to go into a different numbering system called complex numbers. This is a very powerful system. You do this in Calc and Vectors course next semester if you're going to take it.
Yeah, I'm taking it.
So how does this work? In this system, the square root of -1, okay, the square root of -1 is a special character like pi. It's called I for imaginary.
Okay.
Square root of -1 is I, okay? So we're gonna rewrite negative root 49 as 49 times the square root of -1.
Okay.
Okay, what's the square root of 49?
7.
Plus minus 7.
Oh, plus minus 7. Yeah.
And then square root of -1 is I. There we go. This is the answer.
So you just do this in calculus, right?
Yeah.
But it doesn't get like brought up in grade
No.
school advanced functions. No.
Not
Okay,
in
cool.
advanced functions, but it's just something to know, like when they say this has no solution, it actually has a solution. You just have to jump the number system.
Oh, okay. I see. Okay, makes sense.
Alrighty, let's move on. Domain and range. Again, this is going to come again in grade 12.
Yep.
What is the domain and range of this function A? It's a quadratic function. Again, it has a power 2, right? And this is in the vertex form as well, which is good.
Yeah.
So we can just make a quick sketch of this actually. Vertex form. Where's the vertex?
Vertex is, isn't it like, just like up? Isn't it -3?
So you compare this with this, okay? Ax minus h squared plus k. H
Right.
comma k is vertex. So what's h comma k here?
Yeah. Oh yeah. It's so 3, 4. -3,
3,
4.
4. No, just 3, 4. See, it already
Yeah.
comes with a minus sign. So at 3 and 4 is our vertex, right?
Yeah.
And this quadratic is opening upwards. So it looks something like that. Cool.
Okay.
So what's the domain of this function?
X. Okay. No. Y for oh. Okay. Domain. So X can be anything.
Yeah, x is a set of all real numbers. Or X is
The
an
range. Yeah. The range is Y more than or equals
more than equals what?
4.
Yeah, there we go. Perfect. And you're done.
Okay.
Let's look at B. What is this function, by the way?
I have no idea what
Oh, this is a square root function.
square root.
Square root function. Y is the square root of x. But this has been transformed a little bit. It's been flipped on the y-axis and moved 6 units to the right. So in fact, this would be this. Y equals, again, I'll tell you how to identify these when we get to it. But that'll be the equation for that.
It's x equals anything. That's the domain. X is
No,
anything, right?
X won't be 7.
It's the parent function, if I'm not mistaken, in the table, right? Well, I don't have it in front of me right now, but
The parent function is a square root, yeah. It starts from 0, 0. So the parent function, x has to be greater than 0, y has to be greater than 0, domain and range.
Because it starts at 0? Is that,
yeah, exactly, because you can't have, again, the square root of -1 does not exist, right? Because we're doing ER system, the real number system.
Oh, yeah.
We have to start from 0. So this will be the domain and range of the parent function. Now this function has been flipped on the y-axis, shifted 6 units right. What's the domain?
The domain for this one?
Yeah, the transform one, this one.
So x has to be, isn't it the same thing? Just more than 0?
No, x is gonna be less than 6. Look at this. X will never be 7, right? It's going this
Okay.
way. It's going towards the left. So x is gonna be less than or equal to 6. That's the domain.
And then what about the range?
Range, if you just look at the graph, it's gonna be greater than 0. Same as this, no change in the range because it has not been transformed vertically.
Okay, right. I see what happened. Okay.
Yeah, so it's only been transformed twice. Once it flipped and then it went 6 units right. So the range does not change.
Oh, okay. Okay, makes sense.
Let's do some trig maybe. 15 minutes.
Okay.
All right, let's look at this. It says solve for y.
Okay. We just do, so we don't have opposite, right? So we just have the hypotenuse and adjacent, right?
No, we don't have the hypotenuse. Hypotenuse only exists for a right angle triangle.
Right angles, right.
SOHCAHTOA is specifically only for right angle triangle. So you can't use
Oh,
SOHCAHTOA here,
okay.
but you can use sine law and cosine law.
Okay, yeah. So it's isn't it like 23 and 55? So it's like sine 55 over 23.
Yeah.
And then 14.
Let's
Well,
call
like,
this x. All right, so
yeah.
you see sine was in the numerator, so sine is going to be in the numerator on the other side as well.
Yeah, so it's
Sine
sine x over 14. Makes sense.
Yeah.
And then you solve and you find x. And then when you find x, you just add them together, minus 180, and find y, right?
Yeah, exactly. So x is going to be the sine inverse, right? You just multiply both sides by 14, yeah?
Mhm.
14 times sine 55 over 23, and then you take the sine inverse of that. That'll give you angle x. So 14 times sine 55 divided by 23. Take the sine inverse of that. So that's 30 degrees, right?
Mhm.
So 180 minus 30 minus 50. You know this, right? To find the
Yeah,
missing in a triangle, you just subtract from 180. 150 minus 55 is 95 degrees, and you're done.
Okay. That's cool. And it's
Okay.
always sine, if I'm not mistaken, right?
There's also the cosine law. So
When is it cosine? How does it work?
how does it work? So it works like this. You have this guy, 23, 10, 12. This angle is missing. Can't use sine law. Notice you have no angles. Sine law
Oh,
requires you to know at least one angle. Here you have no angles. So here you'd use the cosine law.
so cosine x, is that what we do?
No. So let's say this is C. Let's say this is A. Let's say this is B, okay?
Okay.
So it works like this.
Oh,
C squared.
a squared.
Yeah,
Oh,
exactly. A squared plus B squared minus 2AB times cosine of X or C.
Yeah.
So this is the
Okay.
cosine law you use when you have no angles given.
Yeah. I just remembered. Yeah.
So it says now sketch this function, cosine of 3x plus 2. By the way, advanced functions is the same thing as the functions course, but it's just dialed up to 11. So, so far we've been doing degrees, right? 90 degrees, blah, blah, blah.
Yeah.
There's another measurement system which we will use in advanced functions, and that is called radians.
Okay.
So how does this work? Right angle, so this works like this. A right angle in the normal degree system is 90 degrees, right?
Mhm.
A right angle in the radian system is pi over 2 radians. And the conversion factor is this: 180 degrees in the normal system is equals to pi radians. And from this, you can come up with anything. Let's say you wanted 90 degrees. What's 90 degrees in this system? You just divide both sides by 2. You see, that's how I got that.
Oh, yeah, because 180. Yeah, okay.
And what's 60 degrees? You divide both sides by 3. So you get pi over 3 is 60.
Okay.
So we'll be using this system in grade 12.
Would you say like grade 12 is similar to grade 11? Like
Very similar, but it's just it's trickier.
Oh.
Everything you did in grade 11, everything is going to come back in grade 12. But then there will be extra things like newer things to it, like this system, right? You've done this in grade 11, you'll do the same thing, but now instead of using degrees, 30, 60, whatever, you'll be using like pi over 6, pi over 3, the radian system.
Okay.
Yeah, trig identities, trig equations, everything is going to come back, transformations. But there's a couple of new things. And then there's the entire new function called the log function in grade 12 as well. Looks something like this. It's not bad, it's fun. We'll do it when we get to it. But the question here is asking us to sketch this graph. How do we do this?
Sketch one cycle, or actually when I was doing, this is the only question I didn't know how to solve when I was doing the review. I didn't know, I saw the answer, but I didn't know how he did it.
Alrighty,
Like,
don't worry about it. So any function, all right, again, we're going to be doing this in grade 12 as well. Any function that you can think of has this form, okay? A times f, where f is the function, cosine squared of x squared, doesn't matter. This is the function. Bracket open k, x minus d plus c. So what is an example of this here? Look at this. -2 square root -3 x minus 4 plus 5. A trig example would be -2 cosine -3 x minus 4 plus 5. Okay?
Okay.
Well, what do they both have in similar? They both have a, k, d, and c, right?
right.
So every function will have this thing in similar. So first thing you want to decipher is what a, k, d, and c. Here it's easy. A is -2, k is -3, d is +4, c is +5.
Right.
What is a, k, d, and c here? Cos 3x plus 2.
So your d is +2?
C is +2. See, notice d
Oh,
is
right,
inside
yeah.
the function. So c
Yeah,
is 2. D is 0, all right? Because you're not adding anything to the x, right? Or subtracting anything from it.
Okay.
D is 0. What's k?
K, it's 3.
Yes, what's a?
A is cosine.
A is the number that's outside the function. 1. A is a 1.
Yeah, well, yeah, okay, then yeah, sure. That would be a 1. Okay, makes sense.
And
then
whenever, yeah,
Okay, no, yeah, go ahead.
when D is 0, it has no effects on the transformation. So we're not interested in it. You can just erase it completely. Okay.
Okay.
When A or K is 1, they have no effect on the transformation. You can just completely disregard them.
Okay.
So now any point on the parent function, any x and y value from the parent function in the transform function becomes x over k plus d, ay plus c. Okay. So
Okay.
let's look at the parent function. What's the parent function here?
Cosine 3x.
Just cosine x, yeah, cosine x, the parent function.
Yeah.
So what are some points on cosine x? Cosine x starts here. When it's 0, it's 1. Okay.
Well, sorry, when it's 0, it's 1.
Yeah, cosine x. When it's 0, it's when the x is 0, y is 1. When x is 90, y is 0. Okay, so this is the point. When x is 180, this is -1. Okay. At 270, it's back up to 0. And then at 360, it's back up to 1. This is the parent function cosine.
Yeah, that was like very similar question, if not the same. I'm just a bit lost. So you do 90, 180, 270, and 360, okay?
Yeah.
But when do you know where to put what? Because like I know
You're
it
just
starts
gonna
at
have
1.
to memorize cosine x. You're just gonna have to, or use a calculator. This is the parent function, y equals to cosine of x. Eventually, once you do like a couple of these, you will remember these points.
So it just goes through 90 and
Yeah.
then 180.
Yeah,
and
exactly.
It's just a memorizing thing?
Yeah, you're just memorizing. There's actually a trick to this. You want to know it?
Sure.
I'll show it to you if you're interested. So this comes from the unit circle. Where the hell do these points come from? That's a good question. They come from the unit circle. Okay, what's a unit circle? A unit circle is a circle that has a radius 1.
Okay.
So if you put them on the origin, it looks something like this, right? The left arm is at -1, right arm is at 1, up 1, down -1. Okay, this is the origin. So when you look at this, sine x, or the sine, is the y value, and the cosine is the x value. Now bear with me here. Of the circle, wherever the circle touches the lines, okay? Here, let's look at this. 0 degrees, right? This is 0 degrees. So sine 0. Sine 0 is the y value here. What's the y value here?
0.
0. There we go. Sine of 0 is a 0. Cos of 0. What's the x value here? See, cosine represents the x value.
X is 1.
Yeah, there we go. See, that's how we got our first point. When x is 0, y is 1 for cosine x.
Okay.
And then we keep going. Sine 90 is the y value. What's the y value up there? 1.
Oh,
Cos
I see.
90. What's the x value up there? 0, right?
I see. Yeah, okay. And then
Sine
yeah,
180. Yeah, exactly. This just keeps flip-flopping.
Okay, it's a memorizing thing. Yeah, that makes sense.
Blah, blah, blah. Yeah, something like this. That's how you get this graph, okay?
Okay.
You can memorize this method. So now we had our k is 3 here, and our how do we go? A, K, D, C, your C is 2. So any point x, y on the parent function becomes x over k plus d, or d is 0, so we can just ignore that. It becomes x over k, and then becomes ay plus c, but a is 1, so you can just ignore that. So we can just do y plus c.
Okay.
Okay, and now we're going to plug in the values. K is 3, c is 2. Okay.
Oh, so to show all the crucial points, right?
Yeah, exactly. So what are the crucial points? Our first point was 0, 1, right?
0, 1.
Yeah, so we're going to plug this 0 in here as 0. Plug this
so
1 in here as
0.
0
Yeah.
and 3.
And
There we go.
1. Oh, yeah.
Okay, so,
Okay, I see.
so this point 0, 1 became 0, 3 up there.
Wait, where did you get the x over? Oh, so why did you do x over 3 though?
It's always going to be like that. xy always becomes x over k plus d, ay plus c. Again, it's a memorization thing for any function.
Oh, that's what's it called? That's for like the mapping rule.
Yeah, exactly. This is called a point mapping rule.
Okay, I see what's happening. Yeah.
And you'll do this exclusively in grade 12.
If it was like, if I was dividing, like if it was 1 over 3, it would just be 3, right?
Yeah.
Okay, cool.
And using this, we can just come up with all the other points. The next point is 90, 0. 90 over 3 is 30. 0 plus 2 is 2. So 30 and 2. So somewhere there is our next point. 180, negative 1. Again, you're going to have these memorized once you do a couple of these. This becomes 60 and positive 1. Okay?
Okay, makes sense.
And then we can just keep going like that. And then the next one is 270 and 0 becomes 90 and 2. So it's going to come back up there again. Now you see there's a pattern forming. And then 360 and 1 becomes 120 and 3. So at 120, wherever that is, it's going to be here. It's back up to 3. There we go. We have 5 points here. And again, once you have a couple of these, you can just kind of like extend them, follow the pattern.
Okay.
Approximately left and right. Okay. And then you can have a couple of cycles that way.
That makes sense.
Okay, so for any transformations, we're going to be using this. And there's a lot of functions here, like 7, 8 of them. We'll be just using the point mapping rule. Super simple. Make one table for the parent function and make one using the point mapping rule.
Okay, sounds good.
Same thing here. You see all these fancy terms. Amplitude is, yeah, that's just the A value.
Yeah, I remember all that. The vertical shift and then the horizontal shift.
Yeah.
And all that.
So what's the amplitude here?
2.
2, right? What's the period? Now, period is equals to 360 over the K value.
Oh, yeah, or K. Right.
What's the K here? The K is 1, right? Nothing is being multiplied here. So the period here is simply 360. What's the period here?
360 over 45?
No, 1 over 3. 360 over 1 over 3. K, this is the D value. Okay, A is minus 1. This is K.
Right.
This is D minus 45, and this is C plus 1. So 360
so
over
3.
1 over 3. That's going to be what? 360 times 3, 1080. Okay.
Okay, I see.
Let's look at the phase shift. Phase shift is the D value. What's the D value for A?
Yeah. Makes sense. Yeah, this is old. Sorry, what's the what?
What's the D value here?
D value? Isn't it negative 150?
No, positive 150. It already comes negative, just
Oh,
like the
right.
vertex form. So D is positive. This means it's gonna go 150 units to the right.
But so if it was positive, it becomes negative, right?
Exactly. See right here, B is negative 45. This means this function went 45 degrees to the left. When
Oh,
you
yeah,
compare
so
with the parent function, when you compare, this guy is 45 degrees left.
yeah, so it shifted to the right, like for the A, for A.
Yeah, exactly. Yeah.
And
Yeah.
for B, it shifts to the left.
Yes.
Okay.
And the vertical shift is just the C value. Here it's 0, so there is no vertical shift. Here
And
the
here's
vertical shift is 1 unit up.
so it just went. It shifted to the right one, right?
An up one, up one.
Oh, you just say up one.
Yeah.
So it shifted up one. That's
Yes.
good.
Yes. In fact, no. If you want the technical definition, I mean, I don't know. I don't think people are picky with this. The technical term is this: vertical translation. 1 units up.
Yeah, I write vertical translation. That's what
Yeah.
I'm doing.
So that'll be the vertical shift. Vertical translation, 1 units up. Horizontal translation, 45 degrees left.
Okay.
Horizontal translation, 45 degrees left, like that.
Okay. So for next time, do you think I would need to do more review, or I can get into grade 12?
No, we can jump right in.
You think like I'm good to go, or what's up?
Yeah, I think so. I mean, why not, right? And if you
I
don't
mean, yeah.
understand something, we will go through it. I think you'll be fine. Unless there's some chapters that you completely didn't understand in grade 11.
No, I think I understand most of it. Hopefully, you know. But
Yeah, it's okay. If not, we'll build upon it. Like, we don't need to keep reviewing grade 11. I don't think so.
okay, yeah, that was a good review session. Is it possible for me to get another one on Sunday, or
Sure. What time are you free on Sunday?
same time? Does the same time work or no?
6 p.m. Sunday?
Yeah.
All right. Yeah, sure.
That works?
Yeah.
Okay, sounds good. Okay, thank you very much.
All right, take care. Bye-bye.
Bye bye.